Cool. Okay. Well, up next, we've got we have a duo coming in. So we've got Tom Porter and Colbert Zhu over here from Accenture FusionX Adversary Simulation Team. I'm going to bring them into the stream right now, and hopefully I didn't butcher any of their pronunciations or anything along the way as well too. Good to have you guys on stream. Welcome.
Thank you. Good first
appreciate
try.
Yeah, not bad, right?
No, you got it.
Good. Cool. Well, guys, welcome again. Thank you for doing all this, putting some content together. We're looking forward to it. So what do we got in store for today? What's the workshop all about?
Sure. Can you guys hear me okay? I think
Yeah.
okay. I just tried to share my screen and realized that might have some Chrome permission errors.
Yeah, sometimes. I don't see it yet.
Okay.
I heard something. I heard a boop.
There we go.
Okay.
Excellent. Yeah, appreciate you guys having us on. Quick intro, I'm Tom Porter. I'm one of the red team operators on the FusionX Advanced Adversary Sim team, along here with Colbert. We've been doing training and courses for a long time. We really enjoy it. We really love the idea behind Continuum Con, which you guys put together. We love the Core Stack platform. So thank you for having us.
Thank you.
Well, we'll give you all the floor. You've got the stage, and I guess Anthony and I will bow out for a little bit.
We'll do that thing again. Yeah. So detecting script abuse in Jenkins.
All right.
Off we go. Have fun, guys.
Thank you. So again, I'm Tom Porter. I'll let Colbert introduce himself, and then we'll kick off.
Yep, I'm Colbert. Tom and I have worked with each other for a few years now. We're both red team operators, so definitely from the offensive side of security. But today we're putting on a little blue team cap as well. So a little purple team exercise here, showing you a little attack and defense in Jenkins. So hopefully you all enjoy.
Yeah, thanks, Colbert. As Colbert mentioned, we are red teamers kind of by trade, consultants. Clients come to us, they pay us for our expertise, sure. But if they pay us, $500K for our team to do an ad sim, that has to manifest in a report that's worth that money. So we put a lot of time, attention, and detail into the effort that goes into that report, along with our recommendations. And we don't want to have our recommendations just be, hey, implement MFA, or you need a better network segmentation. Like, there's no empathy behind that in terms of what the pressure and level of effort that goes into the clients that we work with and actually implementing those type of remediations. So what this workshop is part of the process that we tend to go through when we are thinking about how to, we find something technically, it's cool. How can we provide a good recommendation based off that? And we'll sit down and we'll attempt a solution or engineer what that might look like, just so we can understand what that LOE is. And that's the approach we took with this. So once you dive into this workshop, you will see it is partially offensive, partially defensive, very much a purple team approach. And if you go in and if you check out this section in the page 2, Colbert and I, we run a 2-day black hat training course that we've been running for last year or so. We got a new one coming up here at Black Hat USA. It's going to be virtual. So if you can't make it out to Vegas, you want to come out and see what we do here, please check this out. In that class, we cover full end-to-end DevOps attacks. And that is full with OPSEC considerations, discussion on the detection surface of our TTPs. We have a full interactive lab with that. It's all baseball themed, of course, because baseball is, Colbert and I are big baseball nerds. We run a fancy baseball team together. It's kind of our second job. But in that course, we hit GitHub, we hit GitLab, Azure DevOps, all of the knowledge bases and SCM platforms. We go through event-driven automation, Terraform, infrastructure as code, Vault, pivots to cloud. It's all the techniques that we tend to abuse on our AdSim engagements. And this course is one piece of that. Actually, it's even a smaller piece of one of those technologies. We're going to focus on Jenkins, which is a very popular open source build server that's used in a lot of these kind of fragmented type of pipelines. For this, we hyper-focused on a specific technique, script abuse. It's something that's been around for an extremely long time. And to our astonishment, there has not been native logging within Jenkins to detect script abuse until extremely recently. And we're going to talk about some of the challenges around that because this is something that we've been exploiting for a long time. We haven't had a good recommendation, so we decided we'd try to research it and build one. So part of the attack side, you're going to see some tried and true techniques that have been blogged about for a decade. On the defense side, you're going to see something that no one talks about. And we're going to have a few different strategies depending upon which version of Jenkins you're running with for how you could approach that. It's a bite-sized workshop. We when we built this, we didn't want you to spend a half a day or a day going through this content and trying to digest it all. We think you can get through it in an hour, and we think when you walk away from it, you'll have a better understanding of what adversaries are looking for when they target your Jenkins instance, and some tools in your tool belt for how you might go in enabling detection for those type of techniques. Quick primer before we jump into the structure of this. We'll talk a little bit about DevOps and the Jenkins architecture, just so you understand kind of the building blocks of what we're going to talk about, and that will be the framework for how we talk about attacks and defenses. But Jenkins itself sits in this larger DevOps tool chain, and when we think about DevOps, this is by far my favorite definition. It comes from Camify. You can see his website there. It says that DevOps is a cultural and collaborative mindset, enables communication, collaboration, integration, automation between dev and ops. It's the marriage of development teams and operation teams, essentially. We see it with CI/CD. We see it with managing infrastructure as code, monitoring logging systems. It goes all the way up to the planning stage and all the way through to deployment, and then cycling back with feedback, event-driven automation, things like that. That's why when you see DevOps diagrams, they're represented very much in theme with Continuum Con and its logo. DevOps is very similar. When I see this graphic as an adversary, I see attack surface, right? Like there's so many players in this space, and it is extremely hard to have good visibility across this entire spectrum. And that's why it's such a good place for us as bad guys to go to get initial access, to escalate privileges, to move laterally and advance in our objective, whatever it may be. DevOps as a whole, just by nature of what it does, it typically will need the level of access not usually permitted to users because it has to take the source code, it has to build it, and it has to push it to where it's going to reside. If we're trying to pivot to dev, pre-prod, production, QA, wherever it may be, chances are Jenkins is going to have access to it, or at least be one step in the chain towards our objective. So systems like this, very popular. Jenkins had a very large market share in terms of like being the build server of choice across enterprises for the last decade and a half, until some of the more monolithic solutions came across. So like your GitLab CIs, your GitHub Actions, your ADO with its pipelines, they've really starting to take over. But still, in our 15, 20 years of doing offensive security together, we've seen Jenkins in probably 95% of the environments. And some of the attacks we're talking about today have worked in most of those. When you think about some of the more common attacks that you've seen within the kind of DevOps space, especially in CI/CD, obviously first thing that comes to mind is SolarWinds, what happened there. So a lot of software-based supply chain attacks. We often see these systems basically as ransomware as a service because they have code execution, and especially the CHCD systems are intentionally set up to get arbitrary code execution all of its agents that's deploying to. So these just become great pivot points for us for not only advancing and pivoting through systems, but getting a lot of these systems have arbitrary code execution built into web interfaces, which you'll see today with the script console. Typically, to get to these different environments, they have credentials stored within them. They'll have API keys if they need to reach, say, into a Git repository. They'll have maybe some tokens to do that. If they need to push to a system, maybe they have vault credentials for doing that. Maybe there's SSH keys they have for pushing things across. So often, if you can compromise a system like this and dump credentials from it, you can often pivot and have the keys to the kingdom. A quick primer on architecture, and then we'll jump into the attack stuff, the more fun stuff. So I talked about how Jenkins it's open source, it's community driven, it's been around for a long time, at least since the late 2000s, like around 2009, 2010, somewhere in there. So it's been around for a while. It's had a lot of different iterations. There's a lot of versions. They do a very rapid versioning system. So you're never going to find typically a single kind of version standard out there. When you look at different Jenkins instances, you're going to just find a whole hodgepodge of things. The typical use case is laid out in this diagram that you see here. where you have some developer, they wrote some code, they push it to some source code management platform, say GitHub, and then there'll be a hook between Jenkins, where Jenkins will pull in that source code and initiate a build, and then it will run the build. It might perform optional unit tests for code checking. It might do optional security scanning, things SAST scanning, things like that. And then it will go through the deployment phase and maybe a notification phase. And it could deploy straight to, say, a server that's going to deploy to. It might deploy to some type of container registry or an artifactory, some type of artifact store there. Or it might hand it off to, say, a CD server, like a UCD or an Octopus that's more specialized in that. But this is kind of where Jenkins sits in the chain of things. It's often, since it's right there in the middle, it's responsible for so much. It's why it's so juicy to us as an attacker. The way that Jenkins is set up internally, the kind of head node, what used to be called the master, is now called the controller, that Jenkins controller, and they can have several agents tied to it. And the agent's responsible for the actual building of software and executing those tests. They can run in Windows, they can run on Linux, they can run in Kubernetes, Docker. There's a bunch of different agent formats that it can take, and they can kind of scale out horizontally. Most of our interactions we're going to talk about today is going to be through the controller, especially through the script console and the script API, but they can also give you code execution opportunities within the agents themselves. The way that Jenkins actually executes this code is what they call through pipelines. And there's two different types of pipelines. There's declarative and scripted. Feature parity wise, very similar. Declarative, what came along a bit later, it was meant to be a little more user-friendly and more readable for developers. So most organizations have shifted over to declarative pipelines, but we'll show you examples of both. But the key about this is Jenkins and all these pipelines is written in Groovy. So you have to be a little familiar with Groovy. If you're familiar with Java, it's not too bad. It's still a pain. But it's still fairly simple to read. It has this syntax that you see here within a pipeline where you can define what agent you want to talk to. You know, can the first build system come along, pick it up and execute it, or do you want to target a specific one? How do I go about pulling my code? You can define environment variables. You can have different stages for your build. This is how I would actually check out code from Git. I could have my actual build phase, maybe make command, maybe you're doing a go build, Maven, whatever your kind of deployment environment looks like or build environment looks like. And then you have whatever stages you define, maybe for deployment, for testing, they would all be stacked within this pipeline file. And then after that, you can send notifications out to Slack, to Jira, or wherever it may be that you're going to be sending notes to. Scripted is very similar. It's just kind of a different syntax. If you're more of a visual learner like me, this is kind of what the diagram looks like. Kind of the same agents that you saw or players before. You have a developer, pushes the code, hits that trigger or that webhook within GitHub, and then Jenkins takes over. It schedules a job, and then it's going to send that job over to an agent. If you don't have an agent, which plenty of enterprise deployments actually don't utilize agents all that often. They'll just do code execution on the controller as an agent. But you'll send it off to the agent to do the code execution, run the build, and then push out everything after that. The last thing we'll talk about from an architecture perspective is plugins. Plugins are the community's way of extending Jenkins core functionality. You can go out to this website, plugins.jenkins.io, to see the library out there. There's over 2,000. Anyone can submit them. There's a certain kind of standard they recommend, but a lot of them are hosted on GitHub. You can go out and review them. The reason we bring it up here is because later when we talk about detections, we're going to talk about how to actually build your own custom plugin for extending some of Jenkins functionality, and we'll do it specifically around logging with the script console and script API. That said, there's a whole history of vulnerabilities within plugins, and here are just a few. So don't just go willy-nilly installing plugins. Make sure you do your proper review and testing of them before you deploy them in actual production environment. So with that, we do have an attacking Jenkins section side. We go through this in the course when you get in there, but instead of just talking about, we're actually going to show you. So we'll dive right into our first lab here, and I'm going to let Colbert talk us through it while I drive.
Great. So basically, scenario here in this lab is you somehow compromised the credential of some developer within a company. Oftentimes, we find a lot of creds in GitHub in plain text, or maybe just basic C4 encoded. But we somehow came across this credential, and now we have developer rights to this Jenkins. So the first thing that we like to do is just check out the global credential store. So essentially this credential store is how Jenkins manages credentials or secrets. So oftentimes we find credentials or SSH keys for production systems because Jenkins needs that ability to copy the production application over to the destination server. So it's really just a gold mine of credentials and really a #1 target for attackers when it comes to Jenkins. In this case, we see a Jenkins admin credential. So probably good guess is that that user is an admin of our Jenkins instance here. So we're going to try to escalate our privileges from a developer up to this admin user. So here, Tom is going to create a new project within Jenkins. So typically, as a developer, you either have the ability to create projects or generally more often configure them, an existing one. So you could hijack an existing one, but in this case, we'll just start from scratch, just walk you through the Jenkins console. So in this pipeline, malicious pipeline job, basically what we're trying to do is attach that Jenkins admin credential to our project and then dump its password out to our build log. So the way we're going to do this is by clicking on this use secret text or file. So essentially it'll access the global credential store. We will use the username and password secret here. And essentially what it'll do is once it sends this project build to the Jenkins agent, it will attach this variable, this credential into an environment variable that Tom has labeled myvar in this screen. The next step is now that it's in the environment variable, we want to dump the contents of that environment variable. So we're going to create a build step that executes a shell script for us once the project's executed. Now, for demonstration purposes, we want to show you how Jenkins will do some secret redaction. So if it sees the password being outputted in plain text in the build log, it will actually redact it and change it with asterisks instead. But the trick here is it's pretty simple to get around. In this case, we just need to do 2 base64 operations. Jenkins has become a bit smarter in recent months and detects a single base64 encoding, but not 2. But I mean, there's so many ways to do this. Really, the best way, if you're going to do this in a real test or in production, you really want to use asymmetric encryption because you don't want to leave secrets lying out there for the world to see in a build log. So really important to worry about confidentiality when it comes to this attack and use asymmetric encryption if you're doing it for real. So Tom's going to save this project and now run it. And there we go, build succeeded. So we're going to go take a look at that console output. And just to walk through here, so the first print of the secret credential, it shows it was replaced by asterisks. The second one, where we just single base64 encoded, you'll see that there are asterisks there as well. But on the very last and final attempt, double base64 encoding, we will go ahead and decode that twice. In our course, we have a neat little trick about base64 decoding using your browser in case you happen to be on a system that's a bit restrictive. So it's a neat little trick that we like to use a lot on our red teams when we don't necessarily have all of our tools available and don't want to use the command line as well. So there we go. We see that the Jenkins admin user and password credential right there in plain text. And we've successfully escalated our privileges to admin. So now we'll go back and log in as the Jenkins admin user. And now we have the full power of Jenkins available to us. So the big thing that we care about now as administrator is the script console. And this is kind of what was a blind spot for Jenkins admins and security operators before. Things that are executed through the script console generally don't get picked up or logged. So really any abuse of it kind of goes undetected. In this case, we're going to use the script console to just dump the rest of the credential store and grab any other secrets lying around. For this script that we're using, it will also check any plugins that might also hold credentials. So there are credentials stored beyond the global credential store. So you might have to dig around a little bit further to find them all. Here, Tom is copying a Groovy script that can be found in a tool called Jenkins Attack Framework. It was developed by one of our coworkers, Shelby Spencer. Is that right, Tom?
Yep.
And it's been a great tool for us when we're dumping credentials from Jenkins. This is pretty much what we use. So there we go. Here you'll see an SSH key for a Jenkins agent. And if we keep scrolling down, you'll see, I know it's getting covered by that title card, but there are some extra credentials down there and another secret text for you to find if you go through the lab.
Cool. One thing I wanted to highlight too, we do leverage this script. It's great for dumping credentials, but this is raw or just arbitrary code execution. You're kind of limited by your Groovy imagination. This is a syntax or similar syntax that we'll use for just running ad hoc commands. Obviously, this depends on a lot of different things. The version of Jenkins you're running will have different syntax that it supports, and also the backend. You know, if it's Linux, if it's Windows, you're obviously not going to have bin bash sit on a Windows box typically. But if we wanted to just see where we're executing Jenkins home out of, do ls-a, we can see the files here. We'll go through this process too of just seeing what's there and what's available to us in the system. This is also how we tend to identify credentials that aren't coming back. By the way that Jenkins encrypts and stores its secret material, it's always going to have this AQAA prefix. So if we grep through that, we'll find where all those AQAA prefixes reside within various files. And this is where we can find encrypted material, maybe outside of the usual files that we look for. This is where we have found credentials for like third-party plugins, or maybe if users are storing things in strange directories, we find our credentials like this. And then we can use either offline dump of the material with the master key and the Hudson util secret to decrypt these, or we can use the script console to decrypt them. But it all comes through the script console. And then the last thing, well, before I jump into the last thing, what's important here is that Jenkins does have a logger that's built in, and none of our activity, well, all that was different, but this was before we were testing. This was only caught by our custom logger, our script console interceptor. Everything that we just did basically would have stopped right here. So by default, Jenkins will not capture any of this that we've done. Only after we've already installed our plugins and our custom interceptor there that you're actually going to see anything in the log. Same is also true if you work with the script API. So let me log back in because Callie likes to time out. I tried a top command to keep it alive, that didn't work. What I'm going to show you now is how to use a script API to do some other kind of post-exploitation things. This is another script that's pulled out, Jenkins Attack Framework. It's essentially adding an API token for a user that you've compromised. So for this, you could add a token for yourself. It's a great persistence mechanism to just add kind of your own persistent token. You might also add a token for a different user. You might want to execute an action on some other user's behalf to impersonate them for whatever flow you might be trying to inject into. So what we're going to demonstrate is how you can use a script API along with this Groovy script to create a token for the developer user using the admin user. And it's pretty straightforward. Prior to this, what I did is I generated a token, an API token for the Jenkins admin. I won't show you how to do that, but you can do it through the UI. Jenkins API tokens take this kind of format here. And then you send a curl request, you hit the script text API endpoint, and you're passing along as your data the contents of your Groovy script. And what it gives you back is the value of that token. So essentially, I just created a new API token for the developer user that they are likely unaware about because Jenkins is terrible about notifications. So the developer user will never notice this is there unless they actually go into their profile and try to identify that. And again, none of this will actually be caught on the Jenkins server itself, at least with default logging. That's the attack side. Now we're going to start talking about how you might actually go about detecting this. And where I'm going to start is with Jenkins loggers. Jenkins utilizes java.util.logging as its framework for logging. It's terrible, but it's there. It's what we have. The system log by default will not pick up on this activity unless you add what's called a log recorder. The crazy thing, and honestly the driver behind this whole workshop, was that the logger for capturing script console activity did not exist until about 18 months ago or so. It was October 2023, I think, when this actually got released in Java 2.4.27. And yeah, where this actually became available. So that was over a decade of where this was just an open telemetry gap within Jenkins, and probably why so many adversaries gravitated towards it. So one of the questions we'll answer in a later section is, what do you do? Like, what can you do if you're on an older Jenkins version that's prior to this, besides just upgrading, which you probably should? But for, like, forensically, what can you do to know if someone's actually sending bad things towards your script console that you're unaware of? For Jenkins 2.4.27 later, you do have a new interface called the script listener. It will have an internal hook for you to use on script execution and on script output. So you can hook into those and utilize those to either inspect the traffic, potentially even drop it if you set up any type of learning around it. But it will show you the script source, so like actually the contents of the script, and it'll also show you who executed that script, and also it'll show you the exception object, so you can understand the genesis of where that script came from. The script output will also show you what was the result of that script. So a lot of data now as a defender that I can tap into to understand who's actually using that. The default script listener itself, not to be confused with the script listener. Default script listener is Jenkins' kind of base level implementation, like class perspective, of that script listener interface. So it will implement the on-script execution and on-script output methods, and we'll see in the system logger what that actually looks like. So I'm going to go back to Jenkins here in the system log. This is an old one. So this is what the log recorder looks like. So if you go into the system log and you click add recorder, and you give it a name, you add a logger to it, and then this actually is kind of nice. It auto completes for all the ones that are available to you. And you start drilling down and you see that we have, at least on this version of Jenkins 2.504.2, which is the latest LTS, we have this logger available to us. It's okay to start at all, but there are a lot of different levels you could go with, and you can fine tune it down. Most of the messages that we'll be looking for are on fine and finer. But you save that. Now we have the system log. And now if I were to go back into here and execute something at the script console, like I'll just do this plugin thing. Here's an example. We'll run it. This is my output. Go into the system log, go in here, and we see our two methods that are firing. The first was execution of scripts. This is on-script. On-script execution is showing you what was actually submitted to the script console. So that's actually the print line command. And it looks like this ugly error stack trace at the end. That's not a stack trace. It's actually an exception object that the default class implements to, it passes it in so you understand the genesis of where this came from. So you could trace it all the way back to understand where in this thread it got kicked off, follow the path that it took. The key thing that I look at when I'm looking at this is these lines here. Do script tells me this came from the script console. If this said do script text, that means it came from the script API. So those are kind of the two inputs for script execution for admins. The second level of this is what was the output of that script, and you can see that here we listed all the plugins. You can also see the name of the user who executed it, along again with the exception object. So now we have a facility to actually see this data. Again, this was invisible to Jenkins admins for over a decade. That's cool, but we could go a little further. I don't necessarily, maybe I want to enrich that data. The default implementation of script listener isn't bad, There might be more that I want to get out of it. Maybe I want to format it differently. Maybe I want to set it up so I can forward it out to an external logging system or SIM. And one approach you could do for that are plugins. For this workshop, and once you get in there and play with it, we actually built a plugin that does this. And it was our kind of foray into what does it take to build a Jenkins plugin. And we don't go through it in the course in terms of how to build one step by step. I'll just say that's painful, and I hope you like Maven. I don't now. But you can do it, and it's possible. AI is also your friend there, especially if you feed it all of the Jenkins documentation for the version that you're targeting. So I went ahead and installed this. You could do it yourself. If you go to advanced settings, what you'll do in the workshop is we give you the HPI files, which is packaged as. You download it and then you upload it here and you click deploy and it installs the plugin. Don't have to restart Jenkins. It'll just go ahead and start working. We did that in advance of this demo. And here in plugins, you'll see that I have it installed. We call it Detection Toolkit. So you'll see it listed here. We have it enabled. The way to configure it is if you go back to Jenkins, go back to the system configuration, and this is where in Jenkins you configure kind of the system level type of environments or configuration details about it. Scroll down long enough, you'll see our options. So we have enabled script console logging, we've enabled API logging, and you can put in whatever directory you like to store the logs that we're going to generate. The actual code for doing this, let's see if I do have it handy. Looks like this. Again, we are just tapping into the script listener interface. That's why in the log you saw script console interceptor earlier. That's what we called it. We format that. We make sure that we can see the data. We make sure the directory exists. And then this is the output in terms of what we want to correlate. So we grab timestamp user, the correlation ID. If you want to correlate between this and other systems or other events, you could do that. And actually the script content itself. So that's all configured, it's running. Actually, I already had it running when we executed the previous attacks. So here I am in the Jenkins home directory in varlib Jenkins default install on Ubuntu systems. This was the directory that I configured for this plugin. And what it does is spits out two logs. It will spit out a log that has a timestamp and the username for each script that gets submitted. And then anything that's output just gets shoved into this file. So if I look at, say, this one, now I can see, well, a couple things stand out to me. One, we have all the metadata that we're interested in tracking, something that we might want to push to an external SIM. But also notice that this came in through the script API. If you recall, this is what I did via the curl command. And this is when I was adding an API token for a different user. So notice that my user says Jenkins admin, but I am targeting the developer user for generating the token. That's obviously kind of weird. But now we have a mechanism for capturing that level of detail and have it in the log. And if we actually wanted to see what the output of that was, this is where you have to be careful. Yes, we can see all of the output that we ran earlier in script console and script API. You can also see the API token that we generated. You can see the credentials that we dumped. So this is extremely sensitive, but good data to have in terms of understanding if bad is happening. Last thing we show is what do you do in the instance that you are running an earlier version of Jenkins that doesn't support this login interface, or you don't trust Jenkins. If a bad guy actually compromises Jenkins, you don't want to trust Jenkins to log itself and tattle on itself, because they might start manipulating the Jenkins configuration, disabling what's there. And actually, if you go into Jenkins official documentation about the script console, they call it out explicitly. Scripts can bypass all security controls, access all data. It can decrypt your decrypt all the credentials, and they can modify Jenkins at the lowest levels, make it unstable. So that's where something external to the system comes in, and that's where we get into reverse proxies. If you're not familiar with reverse proxy, it's a very simple concept. Usually in a direct connection, you have a user that talks to the Jenkins controller over port 8080 by default, but it could be whatever port you configure, and they just talk directly back and forth. In a reverse proxy configuration, you have this middleman sitting in between. Nginx in this example, where they request on a certain port, and then it's going to do the translation back to the controller, then back to the client in the middle. And this gives us our point for logging that kind of traffic and understanding who is accessing our server in what context. The way that we did it was we used Nginx. I'm going to highlight just a couple quick configurations to understand. You'll get in the weeds in this in the lab. But there's two things to hone in on here with our Nginx configuration. One is our custom formatter, which I have in nginx.conf. This is the format of logs that we want to capture. That's included in our block. And then we have the actual configuration for Jenkins itself, where we set our upstream in terms of how we want to proxy this. And then for our server block, the thing that we really key in on, a lot of this is actually boilerplate. Jenkins has pretty good documentation about reverse proxy setups with a bunch of different popular products, Apache, HA Proxy, and so on here. CloudBees does a fantastic job with documenting these and putting out videos on them. So you have some boilerplate to start with. And then we started modifying that specifically for our use case. We have a location block here. If anything hits a script, managed script, or script text endpoints, and we have to have all of those because it changes per Jenkins version. We have all these settings for it, but the big one is that we have proxy request buffering turned on. This is something that can add some load to the system. This is essentially capturing that post data that comes with each request. Typically, it's not something you do with the proxy setup like this, but you can. We don't want to do it for every request necessarily, only the ones that are really sensitive that we want to get the extra data on for script console access or script API access. So we enable that for those endpoints, and we're going to have an access log that captures it in the style that we previously defined, or the format. Now if I go back to Kali, I'm sure it's timed out again, log back in. I would show you this through the Core Stack app, but it just doesn't play well with the proxy that they're using there. But I can show you from Kali instance. So the difference here, I'm not accessing Jenkins on 8080 like we were before technically. It's going to hit port 80, which is our Nginx reverse proxy. Now I'll log in. My Jenkins admin user. And I'll just go ahead and go to the script console and execute some stuff. I'll show you another thing that bad guys like to do is dump environment variables. This is one way they might do it. See the output here. And now if I go back to my Jenkins server, I'm going to go to my Nginx login where I have it set up. And I have my Jenkins logs. I didn't turn Nginx on. Am I in the right box? There we go. And start. Jenkins. What am I doing wrong, Colbert?
It seems okay. You want to just try it through the script text API?
Yeah. Oh, I know. That's good. Let's try that. It also gives a chance to look at Jenkins attack framework. So we talked about Jenkins attack framework a little bit earlier. Some of the things that it can do. It can dump the system credentials through the API. Did over port 80. Now I did over Nginx. There we go. Now it's not coming through. This is the first time it hasn't worked. Shocker. Should have recorded this. Now it works. There we go. So with our Nginx reverse proxy setup, we can now see that we have a full logging of the request coming in, as you would expect from a typical proxy log, right in the managed script or endpoint. And then the neat part is that we have what was actually submitted. If I can type. So now, because we have the request buffering turned on, we can capture the full payloads. It's very ugly. It's URL encoded. We could try to capture that and see it a little more pretty printed. But now we have a third-party system that is capturing data heading to sensitive endpoints outside of Jenkins in case we don't trust it. And depend upon your logger of choice, you can set up, file B to forward Sonic Kibana, or whatever SEM agent you want to for automatic forwarding. There's a Jenkins plugin called Audit Trail, which will do automatic log forwarding and rotation for you. But you have these logs, you can shuttle them out, and now this is something that is at least in your toolkit, depending upon what your Jenkins environment looks like. But thank you as I struggled through that demo. But I realize that pretty much brings us to time too. So I hope you guys enjoy the workshop. We all have fun putting together. Thank you, John, Anthony, the whole team for having us. We had a blast doing this. We hope people enjoy the workshop.
Hey guys, this was awesome. I love to see it. Thank you,
Very
thank you,
awesome.
thank you for putting it all together. And hey, yeah, making through the show. I know there are always a couple speed bumps, but hey, that's live demos, right?
Yeah, we figured it out,
Demo
yeah.
gods and all.
Yep. Yeah, looking real good. Was there anything that you did want to cover in like a minute or so? Because you kind of felt bad. You kind of came to a hard stop. Is there something you wanted to talk a little bit more? Because we can probably do like an extra minute or so.
Yeah. I don't know if anybody kept an eye on chat. Colbert, any questions that came through?
I think there were a couple questions if you want to just jump to questions now.
Sure.
Okay. Yeah. Let's take a look. I'll scroll up over there and see what we're kind of looking at.
Oh, let me take that down. I was getting a little too preemptive for me.
Just gonna remove that real quick. There
Thank
we go.
you, sir.
Yeah. Okay. Questions, everyone.
How common is it? It's extremely common. Like I said before, I'm a red team consultant. I've been doing it for over a decade now, and I find it in probably 95+% of environments. The only ones I don't see it in are people or organizations that are more small and lean, maybe startup, that are using the monolithic all-in-one solutions. But almost any enterprise of sufficient size is going to have a Jenkins dangling out there somewhere, and mostly by a developer because they can just install it on their local machine and run it to test things. They're out there.
On that question there, though, let's just say general, how relative is this workshop compared to other CI/CD types of tools, or just conceptual translation to other types of things? What do you think about that?
Sorry, how relevant is it?
Yeah. Like, let's just say someone hasn't used Jenkins, or they're using another type of CI/CD tool,
sure.
or itself. Like what you covered today, how would you say that is transferable, or can be applied?
So the approach is, so I guess we very much take a purple team approach to our recommendations and how we build things. So we want to play with them, understand the technology before we start recommending solutions to them. The concepts here, though, are directly applicable to any other type of CI/CD solution you might have in place. We take the same ideas and we apply it to whatever the build server is that organization is using. It might not be Jenkins, but likely it has a credential store that you can dump. It might have code execution on agents that you can take advantage of. We do this all the time. And we just don't know what faculties those systems have for logging. So you have to dive into them, figure out what's available to you, and take advantage of it. Some of the more mature, recent things like GitHub Actions, GitLab CI, ADO pipelines are a little more sophisticated and give you more tools. Some of these kind of more bespoke technologies that are Frankenstein into pipelines, you got to figure out yourself.
Cool. Good. Yeah. Hope that helps the chat as well too, and they're thinking about other tools. Let's see if there's any other questions popping up.
Demo, same as your Black Hat training. No, if you come to Black Hat, you'll see something entirely different. We have a pretty massive environment where we walk you through. It's full end-to-end pipelines. and your job is to do recon and initial access and privask and lateral movement, and you'll walk through all the way to getting not only code execution at the kind of production or endpoint systems, but also trying to simulate real world objectives, getting access to PII or trade secrets, or get into backend databases, or pivoting out to cloud. It's a lot of fun.
Yeah, the training is definitely more red teamer focused, but we've had security operators from both ends, blue teamers, developers that are looking to secure their instances take it, and there's definitely things to be learned as a defender from the training, but definitely more from an offensive side.
Very cool. Little appetizer over here of training.
Exactly.
Mm-hmm.
And it's always, hey, knowing the offense makes a better defense. Right?
Exactly.
So,
And that's why we research the other side, so we know how to evade these detections or figure out how hard it is for them to implement something like this.
And in the course too, we go through, like, we hyper focused on script abuse here, but we use Jenkins for reconnaissance within LDAP, for getting access, roundabout access to source code repositories that we can't get through SCM. We go through hunting credentials and build logs and parameters, pivot points. I mean, a lot of different things that Jenkins opens up to.
Cool. Well, we can give another minute over there. I think that was a pretty strong closing workshop for the day over there. Tons of content takeaway. Can't believe that this... I know John and I said earlier, right? Like, a lot of these are like literally micro courses. This is literally like a micro course. Like, there's so much to unpack and take away for everyone that's going through this workshop. It's huge. Awesome.
Yeah, appreciate it. We had a lot of fun putting it together. And thank you guys for having us. This was great.
Definitely enjoyed. Cool. Well, not seeing other questions pop up over there in chat. So kind of... let's just remove that for a quick second over there. But yeah, thank you, Colbert, Tom. Thanks for putting this together. Thanks for being with us, putting all the work into this workshop, literally. And yeah, thanks again. And thank you everyone in chat for engaging with the workshop. Some good questions over here. Tom, Colbert, anything else you want to plug? Any last comments? Anything you want to throw out there?
Appreciate you guys having us. We are, I mentioned that we'll be doing our Black Hat virtual training for USA. But we'll also be bringing an in-person training to Black Hat in Europe, in London, in December. So if you're out that way, want to come stop by London, come on out. Love to see you.
Nice. Well, you heard it directly from Tom. So get out there and go hop in the training. Thank you, Colbert.
Guys.
Thank you, guys.
thanks so much.
Cool.